to solve this problem using the y equals kx approach. We're now going to show how to do the same problem using the butterfly method. If you've already watched the breakdown of this problem for y equals kx, you can skip this first part. If you haven't, I would recommend you do watch this part because it lays out the thinking that you will need to know how to use. Okay, these two maps show the same area at two different scales. Columbus is not on map A. Here I see Columbus on map B. It's not on map A. It looks like it would probably be somewhere over here if it was shown. Let's keep going. Map B does not have a scale written on it. I see here on map A, it says 1 centimeter is equal to 40 miles. So any 1 centimeter on this map A corresponds to a real life distance of 40 miles apart. For map B, that's not provided. It next says Riverside and Gladville are 6.8 centimeters apart on map A. So on map A, these are, line's a little crooked there, 6.8 centimeters apart on map A. On map B, Gladville, or rather Riverside and Gladville are 3.4 centimeters apart. And then lastly, Gladville and Columbus are 1.8 centimeters apart on map B. 1.8 centimeters apart on map B. Determine the straight line distance in miles from Gladville to Columbus. Okay, I need to get very clear on what I'm being asked. Notice that they're actually not asking me for the distance from Gladville to Columbus on map A. They actually want the actual distance in miles between Gladville and Columbus. Now the problem is we have the distance between Gladville and Columbus on map B, it's 1.8 centimeters, but we don't know how that translates to actual miles because there's no scale on map A. So we need some sort of strategy for how we're going to get from 1.8 centimeters all the way to an actual distance. Well, if I can use this pair of corresponding values between Riverside and Gladville, since I have that for both of these, I can find the constant proportionality that'll take me from map B to map A. And then if I get to a map A distance, well, then I can use this pair to go from centimeters on map A to actual miles. So I'm going to draw like a little graphic here to kind of lay out my plan. So the value I'm given here that I'm kind of starting out with is this 1.8 centimeters. That's all I know as far as Gladville to Columbus. So I'm going to make the distance on map B is going to be my input. So distance on map B, this is going to be my input, or my x, right? This is in centimeters, all right? This is where I'm starting first. And then from there, it's going to get scaled up to our output, y, output's always y, input's always x, to the corresponding distance on map A. So I'm going to call this M with a little a for map A distance, right? Not talking about the actual distance, I'm talking about the map A distance, right? And that's unknown. We don't know how far that is, okay? After this, laying out the whole strategy for the problem, after I've done that, I'm then going to use this map A distance. So my new input is actually going to be the output from my last solution process. Now my input would be my map A distance in centimeters, right? Distance on map A. And I'm going to use this pair to find the actual miles. So I'm just going to put big A for actual. Actual distance in miles. So this is going to be my output, right? So I'm end up going to be using the butterfly method twice, okay? This is the process I'm going to use here, okay? All right, I'm going to need to clean this up to make some space here. Let's see. I want to keep this over here, so I'm just gonna kind of come over here, make some space. That ain't gonna work. I'm gonna get rid of this. All right. All right. So for my first butterfly method, unfortunately, I had to erase that to make some space. But the first thing I'm gonna figure out is using this pair. Let me switch my color here. Using this pair with map B being the input and map A being the output. So it's going to be map A. Remember, it's always output over input over map B for Gladville to Columbus for both of them. And then we're going to go map A over map B. But for my pair that I do know, for Riverside to Gladville, okay? Notice how it's map A over map B for both of them, right? Output over input for both of them, okay? If I had one of these flipped, if it was B over A on this side and A over B on this side, I would not get the problem right. The fractions would not be equivalent. The ratios would not be equivalent. All right. So let's go to our pair here. Let's go to the values we do have. So for map A, Riverside to Gladville is 6.8. So it's 6.8 centimeters for map A. Riverside to Gladville for map B is 3.4. Remember to find K. Well, we're not finding K here. We kind of are, but we're not using the y equals kx approach. But to set up a ratio, you always need one of your ratios is going to be composed of y over x for a pair that you do know. Okay, it really is k actually. So 6.8 divided by 3.4 or over 3.4. Now let's go to this side. So for map A, Gladville to Columbus, we don't know what that is. Okay, so I'm going to put m with a little a for my variable. And then for map B, the distance that corresponds to the distance between Gladville and Columbus on map A, well, on map B, that's 1.8. So it's A over B equals A over B. This is A over B for the pair we know, with setting it equal to A over B, or output over input, including the variable we don't know. And now we can cross multiply to solve for the unknown. And we have 1.8 times 6.8 equals m little a, or m sub a as it's called, times 3.4. Okay, equal sign, this times this equals this times this. 3.4 ma. Okay, I'm going to multiply out this 1.8 times 6.8, and it's going to give me 12.24 equals 3.4 ma. Now to solve for ma, the map distance on A of Gladville to Columbus, I'm just going to isolate the variable, and I do that by dividing both sides by 3.4 to get rid of this 3.4. Now this is going to cancel. 3.4 over 3.4 is 1. So m sub a equals 12.24 divided by 3.4. You could do long division. For this one, I'm just going to show what it equals. Divided by 3.4 is equal to 3.6 centimeters, right? Because this is the map A distance. So now we know this distance on map A is 3.6 centimeters. But before I say that I'm done, let me go back and read the question. It says determine the straight line distance in miles from Gladville to Columbus. Okay, so I need to now convert this to miles. And when I'm using the butterfly method, I'm always just looking for a pair. Just like when I'm finding K, I'm always looking for a pair, right? And I'm going to make some space now. Use a different color for this second part. Is that clear? All right, a little dark, a little brighter. All right. So now we're going to use this pair and an input of 3.6 centimeters to figure out a corresponding output of Gladville to Columbus in miles, okay? So we're going to set our pair equal to an input and a value we don't know that we're trying to find, okay? So we're going to set it up like this. It's always output 1 over input 1 equals output 2 over input 2. So if I set this up correctly, it should be miles over centimeters equals miles over centimeters. One of them is going to be a pair, and one of them is going to include the unknown with the input that corresponds to the unknown. Okay, so the output 1, we can make this be the one we don't know. The order doesn't matter as far as which side you put it on. The order as far as top to bottom definitely matters. So our output that we're seeking is going to be this distance from Gladville to Columbus in miles. And I called that before A, just for actual distance. Actual distance in miles. You can call it anything that helps you keep it straight. And the input that corresponds to that is going to be this 3.6, this map distance of A, okay? So this is actual distance in miles over the map distance from map A, okay? And that's 3.6. And then do we have a pair? We do. We have this pair right here. Again, it needs to be miles over centimeters. So for map A again, the output, if the output is 40 miles, that corresponds to an input of 1 centimeter. Okay, let me make sure I set this up correctly. I have miles over centimeters, and A is miles. That's what I'm solving for. That's my unknown, distance in miles, so that's good, equals 40 miles, which corresponds to 1 centimeter. Those definitely go together. That's a pair, and it's the output of miles over the input of centimeters. We're good to go. Let's go ahead and now cross multiply to solve. So we got 3.6 times 40, 6 times 40 equals 1 centimeter times A. So it's 1 times A, which this is just going to be A, right? 1 times A, that's just A. And now let's go to multiply this. And this is, if you want to see how beautifully the units cancel, I'll go ahead and add the units here, which is just further confirmation that you did it right. This was 1 centimeter times A, 1 centimeter. This is 3.6 centimeters. This was 40 miles, right? So I'll put this back so you can see how the units cancel. 1 centimeters equals 3.6 times 40 gives you 144 centimeters times miles. That's weird looking. Centimeters times miles. But now we're going to divide both sides by this constant of 1 centimeters. You wouldn't need to show all this using the units, but this is just to kind of get advanced, help you out for chemistry. Centimeters will cancel, and look at that, how nicely that cancels out. 144. Only unit left here is miles, and that is just further confirmation that, yeah, I did this correctly.